Have you ever gazed up at the heavens and wondered about the origins of life? What if the answer lies in the icy bodies we call comets? Comets, these enigmatic celestial bodies, could be the key to understanding our cosmic roots. They are not just glowing balls of ice and dust hurtling through space, but rather intricate time capsules from the dawn of our solar system. Imagine a comet as a primordial snowball, composed of ancient ices mixed with dust. This icy concoction encapsulates the raw materials from which our solar system was born. And within these icy bodies, a rich diversity of organic molecules, water, and various other compounds are preserved, frozen in time. These comet constituents are not just ordinary substances. They are the fundamental building blocks that have the potential to illuminate the chemical pathways leading to life. Just like time capsules, these icy bodies journey through space, carrying with them the secrets of our cosmic past. Our journey begins billions of years ago in the cold, far reaches of the solar system. Here, in this celestial nursery, comets are born from an ethereal blend of dust and ice. These particles, relics of the early solar system, dance in the darkness, slowly coalescing over millennia. As they come together, they form a nucleus, the heart of what will become a comet. Imagine this process continuing, with more and more particles joining the dance, adhering to the nucleus and causing it to grow. Over millions of years, these icy bodies form and drift, kept in the deep freeze of space, perfectly preserving the chemical signature of their birth. These icy bodies reside in distant reservoirs known as the Oort cloud and the Kuiper belt. Picture these regions as vast, frozen storehouses of comets, lying in wait on the fringes of our solar system. Here, they remain dormant, locked in a cosmic dance with the sun, their orbits determined by the delicate balance of gravitational forces. Yet every so often, a gravitational ripple, perhaps from a passing star or the tidal pull of the Milky Way galaxy itself, disturbs this balance. This disturbance can nudge a comet out of its stable orbit, sending it plunging into the warmer, inner regions of the solar system. As the comet gets closer to the sun, it begins to heat, and the icy nucleus starts to vaporize. This process gives birth to the comet's coma and tail, those iconic features that we associate with these celestial wanderers. These features are not just beautiful to behold, they also contain valuable information about the comet's composition, and by extension, the early solar system. And so, a comet embarks on its epic journey, carrying within it the pristine ingredients from the dawn of our solar system. As we delve deeper into the life of a comet, we'll discover how these icy time capsules have the potential to reveal secrets about our cosmic origins, and perhaps the origins of life itself. Now imagine hitching a ride on one of these comets. What would you see? Picture yourself on a cosmic roller coaster, plunging through the vast expanse of the solar system. As you journey, you'd see the sun, a distant, radiant beacon growing closer and closer. The planets, once merely distant points of light, gradually take shape, revealing their unique features: the stormy bands of Jupiter, the ringed beauty of Saturn, the red hue of Mars. But the real show begins as your comet nears the sun. The once frozen nucleus of your icy steed begins to stir, responding to the sun's increasing warmth. This heat triggers a transformation. The solid heart of the comet, a mix of ice and dust, begins to vaporize. As it does, it releases a cloud of gas and dust, forming an ethereal shroud around the nucleus known as a coma. The closer you get to the sun, the more intense this process becomes. The sun's heat and its solar wind, a stream of charged particles, interact with the coma, sculpting it into a magnificent tail. This tail, which always points away from the sun, can stretch millions of miles into space, creating a celestial spectacle visible from Earth. But this isn't just a performance for our eyes. This process of vaporization and tail formation is a chemical reaction on a grand scale. As the comet's icy nucleus vaporizes, it releases a cocktail of molecules: water, methane, ammonia, and a wealth of organic compounds. These are the very elements that are essential for life as we know it. So, as you ride this cosmic Voyager, you're not just witnessing a beautiful celestial event. You're watching a chemical time capsule from the dawn of our solar system unravel, revealing its secrets in a display of light and color. As they streak across the sky, comets are not just a spectacle to behold, they're a window into our solar system's past. But comets are more than just cosmic voyagers, they may have also been cosmic delivery services. Imagine a time, billions of years ago, when our planet was young and going through a period of heavy bombardment. It was a chaotic era, with celestial bodies of all sizes colliding into one another. Among these celestial bodies were comets, icy wanderers journeying from the outer reaches of our solar system. These comets, brimming with a cocktail of water, organic molecules, and other compounds, impacted Earth. As they did, they could have deposited some of their precious cargo onto our then barren planet. In essence, they could have been the interstellar delivery guys, dropping off parcels of water and organic material. Now, why is this important? Well, life as we know it requires water. Water is the solvent in which all the chemical reactions necessary for life take place. And the organic molecules? They're the building blocks for everything from DNA to proteins. They're the ingredients for life. But here's the catch. Back in Earth's early days, conditions were not conducive to the formation of these essential molecules. So how did they get here? The theory is that comets, acting as cosmic delivery services, could have brought them to Earth. Several comet missions, like Rosetta and Stardust, have bolstered this theory. They've discovered a rich diversity of organic molecules in comets, similar to those found on Earth. They've also detected water, giving credence to the idea that comets could have delivered the oceans that cover our planet today. So, these icy wanderers, once considered mere relics of the early solar system, have taken on a new significance. They're not just cosmic voyagers, but could also be the carriers of life's ingredients, having played a crucial role in shaping the world as we know it. Could these icy wanderers have seeded our planet with the building blocks of life? The evidence suggests it's possible. To unravel these cosmic secrets, we've sent missions like Rosetta and Stardust to study comets up close. These missions have been our cosmic detectives, peering into the past to uncover the mysteries of the early solar system. The Rosetta mission, for instance, made history when it rendezvoused with Comet 67P/Churyumov-Gerasimenko. For over 2 years, it studied the comet, documenting its journey around the sun and capturing intimate details of its icy nucleus. The probe's instruments detected a rich tapestry of organic molecules, water, and other volatiles, validating the theory that comets could be the couriers of life's essential ingredients. Similarly, the Stardust mission, which chased the comet Wild 2, returned with microscopic particles from the comet's coma. Analysis of these particles revealed a surprising diversity of organic compounds, further reinforcing the notion that comets are more than just chunks of ice hurtling through space. These missions also uncovered new and unexpected findings. For example, Rosetta found oxygen molecules in the coma of Comet 67P, challenging our understanding of the conditions prevalent during the formation of the solar system. But the intrigue doesn't stop there. The discovery of complex organic molecules, some of which are precursors to amino acids, the building blocks of proteins, hints at the tantalizing possibility that comets could have played a crucial role in the emergence of life on our planet. These missions have not only confirmed the presence of life's building blocks in comets, but they've also deepened our understanding of our place in the cosmos. By studying these icy time capsules, we're beginning to unravel the intricate cosmic dance that led to the formation of the solar system, the Earth, and ultimately, us. And as we continue to probe these celestial bodies, we're bound to uncover more secrets, further illuminating our cosmic origins and destiny. So, what does all this mean for the search for life elsewhere in the universe? Well, it's quite profound. Astrochemistry, the study of chemical processes in outer space, ushers us into a universe brimming with possibilities. Comets, these icy relics from the dawn of our solar system, are more than just celestial spectacles. They're floating laboratories offering us invaluable clues about the origins of life. Their diverse chemical compositions, rich with organic molecules and water, hint at the possibility that life's ingredients are not unique to Earth, but rather a cosmic commodity. And if comets could have delivered these seeds of life to our planet, who's to say the same couldn't happen elsewhere? The study of comets, therefore, broadens our understanding of life's potential beyond our home planet. As we continue to study these cosmic time capsules, we may not only unravel the secrets of our past, but also spark new questions about our future.